Hi Sally. So what we did today was we actually figured out how to calculate reaction time. And I'm hoping that Mr. Person will remember how to do it. But if he doesn't, this should help you. So in class we actually took a ruler and we dropped it. And attaching it, you're able to determine by the distance actually how much time passes between when the ruler was let go and when you actually caught it. So hopefully Chris has a few numbers which are the distances, or in our case the displacements, that he caught the ruler after it traveled. And let's say, for example, it's 5 centimeters. And he did it a few times, and let's say the average was 5 centimeters. So he should have a bunch of numbers. What we're going to do first is get the average of those. And because it's a displacement, we say it's a vector, and therefore vectors have positive and negative signs that mean direction. So because it went down, we say it's a negative. If it had gone up, we would say it was a positive 5 centimeters. The other thing is, in physics, we can't use centimeters. We have to convert everything into meters. So we're going to take that negative 5 centimeters, and we're going to do the old field goal posts, the train tracks, the kids call it. And we're going to say centimeters on top, so the centimeters have to go on bottom, meters on top, so 1 meter is 100 centimeters. And kids should know how to do this. Negative 5 times 1 divided by 100, the centimeters cancel, you're left with an answer in meters, and it would be 0.0 negative 5 meters. So the next piece of the puzzle is to create this chart, and I tell the kids to make this chart every time they do a physics problem. BI, BF, A, T, D. And the D stands for displacement, which in our case is negative 0.05 meters. The T is what we're looking for because we're trying to calculate the displacement time. Acceleration, because it is in fact a projectile, is always negative 10 meters per second squared. The BF we don't really care about because we're not concerned with how fast it's going. We're only concerned with how long it took Chris to catch it. And the initial V is the initial velocity of the ruler, which was 0 meters per second. So VI is initial velocity, VF is final velocity, A is acceleration, T is time, and D is displacement. And all this is stuff that Chris read. We went over in class. There was a previous video actually on this same page, Happy Physics Land, that goes through all that stuff. So maybe it wouldn't hurt in your infinite spare time, I know. But if you want to sort of keep pace with him, I try and put a lot of this stuff into these YouTube videos. So we'll see if it works. I don't know if it's going to work for the year, but I'm trying it. The next little piece is Chris should have this equation written down. D equals VIT plus 1/2 AT squared. And D stands for displacement, and the displacement here, we're just going to fill in what we have here to what matches and corresponds in this equation. So negative 0.05 meters equals VI, which is 0, times T, so anything equals, any of this right now is going to equal 0. So it's kind of relevant, plus 1/2 A, which is negative 10 meters per second squared, times T squared. And all we're going to do is solve for T. So, I gave the kids the option of dividing by 1/2. For me, I think it's easiest to just distribute this 1/2. So you're going to see negative 0.05 meters equals negative 5t squared. And I usually am much better about carrying the units through, but just for you, let's just deal with the numbers. So divide both sides by negative 5. You're going to get negative over negative is positive, so you're going to end up with 0.01 equals t squared. And then all you got to do in order to calculate t from t squared is take the square root. So the square root, let's get my calculator here, of 0.01 is 0.1. So t is 0.1 seconds. And That's kind of how you do it. So the time is 0.1 seconds. That would be his reaction time. Thank you very much, Sally. And